I want to start. We just opened another cooperation in Melbourne, in addition to our offices in Frankfurt, Vienna, and Paris. To give you a short overview of what we have been doing, one called this is the Karlsruhe Fair Hall, Europe's largest span timber structure. We did strange things like the Kunsthaus in Graz. We have been a close cooperation with the architects of Coop Himmelblau, with whom we did the BMW Welt in Munich. And we do several high-rise buildings in Frankfurt. We completed this Opernturm with Christoph Meckler. We have under construction in Vienna City Tower with Dominique Perrault, and one of our most prominent projects where construction work started in spring this year at the new headquarters for the European Central Bank in Frankfurt, which is, as I said, under construction. Completion will be in 2014. Before I start with the Rolex Learning Center, I want to present another building we did with the Tokyo-based architects of Sanaa, which is Katsuya Sejima and Ryo Nishizawa. In Essen at Zollverein, oh, sorry, just the wrong button. There was a competition for a design school, and the architect developed this design of a concrete cube with a length of 35 meters. A challenging task, since the building should be exposed concrete to the outside and also to the inside. And to reduce the thickness of the wall, we could use a technique that is quite unique and is only possible on this special area, since this is the area of a former coal mine, where they still have to pump more than 20 cubic meters of water with a temperature of 25 degrees per hour. And until this building, they just give it away. And we use these pipes to let this water flow through the exterior walls, and with this technique we eliminate completely the thermal losses of the building. In the planning team we call it active insulation. But as I said, such a thing is only possible at this specific spot. As you can imagine, from this building, to integrate the reinforcement, to integrate this piping in the exterior walls was quite a task. The thickness is only 30 centimeters with a clear height of 9.5 meters. This is the first floor inside the building, quite a unique space. So if you ever have a chance to go to be in Essen, it's really worth to go there. But not only the exterior walls, also the floor slabs got an additional piping for thermal activation. So, as I said, we have been lucky with the company. I must not tell you what difficult you have to, what experience you need to get at the end such a almost perfect exposed concrete surface. This slide gives you an impression of where the idea of the architect came from. To develop this concrete cube, it was the forms that are already there. Steel brickwork structure, which was built in 1926, translated into present times. But now I want to speak about the Rolex Learning Center. It was a competition. We've already been involved in the competition together with with the architects, again Katsuya Sejima and Ryo Nishizawa. This is the model of the competition, animation of the competition, and this is one way to build such a structure. This cake was done by the team of the restaurant of EPFL for the groundbreaking ceremony. So it's just a one-story building sitting on a parking garage, and we have this landscape where the all the activities shall take place. Is a concrete structure, and upon this concrete structure we have a regular grid of steel columns, and on top of this a roof which is made of timber and of steel. So for us the real challenge was this concrete shell, which I really do not want to call shell. It's more it's a concrete plate with a certain curvature, and due to this curvature we have a lot of compression forces inside this shell. So as you see here on this side we have a slenderness ratio of 1:21, and I think there are not much shells around with such a slenderness. Of course, in Switzerland we know the beautiful work of Heinz Isler, who did this beautiful lightweight concrete shells. But these shells are not accessible. These shells are just roofs. So what we had to build a curved concrete structure should be used by people, and which also has to take the loads of the additional roof and all the people inside the building. When we start the design, it was quite a complex optimization process, optimization in plan. As you see here, we had to establish clear load path, and also a very difficult optimization in section. Since you can imagine, the shell had to be accessible, and it cannot be symmetric. To what degree it can be non-symmetric, we had to define, we had to discuss with the architect. Quite a very, very time-consuming process also. And at the end, we ended up with this type of structure, clear load paths. How do you build the section? A lot of alternatives have been discussed, including steel pipes, including a composite structure, and at the end we ended up with a monolithic concrete structure with certain areas where the thickness is a bit thicker. So that's what we call the main arches of this shell structure, and this is the structure as it being completed as a concrete structure. Here you get an idea of the slenderness of this curvature.